First things first, I just want to say thank you guys for the hard work that you've shown during shelter in place. I know it's not easy. I know it's difficult to maintain your sanity while being forced to stay indoors unless you have an extreme need like getting groceries or taking care of a family member. But I know it's not the easiest time to be learning calculus. So believe me, I acknowledge your hard work and thank you. It means the world. It also brings me back to when I was in college, where I was in the tutoring lab and students would line up, especially calculus 1 and algebra 1 and algebra 2. But there were certain times in calculus during the semester where it was like clockwork. I could tell, there's going to be a big demand here. The professors are talking about chain rule. What does that mean? The professors are talking about tangent lines. What does that mean? But today in particular, this is when the majority of the students would flood my tutoring lab and go, I want Matt to teach me this. So I'm here to make this as easy as possible. And forgive me if I firmly believe that if it applies to algebra, it applies to calculus in a more complex way, but it's easy to understand if you go, this is algebra, this is algebra. So without further ado, we look at the graph y equals x squared. Look at it, it's the shape of a parabola. If you can understand a parabola, you can understand pretty much all of calculus. So if you can master the parabola, you've got calculus. So we've got negative 3, 9, negative 2, 4, negative 2, 4, let me slow down a little bit, and then negative 1, 1, and then 0, 0, 1, 1, 2, 4, 3, 9, and so on and so forth. So you notice that it's a curve. It's the earliest example that we've learned in algebra of what a curve is. It's not a straight line. So my goal, though, is to calculate the slope anywhere on a curve. Because we can do it with lines, well, we can get exponentially closer and closer. And if we get closer and closer to a particular point, let's go with 3, 9, we want to figure out what the slope is. Well, if we get close enough, we get a line. Well, we've moved beyond that. We're smarter than that. We have what's called a derivative to do that. So without further ado, let's just make this easy. Let me get my multicolored pen. Okay. So let me put my laptop on the side. They said, the expression, oh, I could do this in my sleep. Well, I'm in my bed sheets right now. It's a Saturday afternoon. So literally, I'm doing this in the place where I sleep. So without further ado, if you have the graph f of x is equal to x squared, you've got f prime of x. F prime of x is done by the power rule. We get 2x. So if I want to figure out the slope at x equals negative 5, we do 2x, but we plug in x equals negative 5. So the slope at x equals negative 5 is negative 10. And the slope at x equals 5 would be 2 times 5, which would be positive 10. Let me just get these out of the way. So now that we know that if we take the derivative, we can calculate its slope. 2 times 5 is 10, which means at x equals 5, the slope is 10. At x equals negative 5, the slope is negative 10. And no, just because you do the positive versus the negative equivalent, that doesn't mean that it mirrors. You can shift the graph. You can bend it. It'll be different. The slope at x equals negative 4. 2 times negative 4 is negative 8. Okay, starting to flatten out a little bit. The slope at x equals positive 4, we get 8. All right, let me get this out of the way. Okay, so the slope at x equals negative 3. 2 times negative 3 is negative 6. 2 times positive 3, 2 times 3 is positive 6. The slope at x equals negative 3 is negative 6. The slope at positive 3 is up 6, right 1. The slope at x equals negative 2 is negative 4. The slope at x equals positive 2 is positive 4. And the slope at x equals negative 1 is negative 2. And the slope at x equals 1 is positive 2. So the reason I had it written out this way is you notice from the left side of 0, 0, the slopes start to flatten out. And from the right side, they start to build up a little bit. So I'm going to bring the visual out again. You can see that at x equals -5, let me zoom that up a little bit, so at -5, that's a pretty steep negative slope, and at x equals 5, that's a steep positive slope. But as we get closer and closer and closer to the vertex, it starts to flatten out until we wonder, well, what's really going on at 0, 0? So let me turn the page and let's get to an important aspect of calculus. So what's going on at f prime of 0? Well, remember f of x is x squared. The derivative of f of x is 2x in this case. So f prime of 0 is 0. So what that means is the slope at x equals 0 is 0. Which, if we remember, we're calculating the slope of the tangent line. The tangent line touches the curve at a particular point to reflect the slope at that time. So if we look at x equals 0, the slope is horizontal. When that happens, we can draw a tangent line, y equals 0, and it touches the curve flat. You can see how this relates to the current situation that we're in. We're trying to flatten that curve. In other words, if you really want to know what those scientists are doing, like, I understand the basics of what they're doing. I'm just a teacher. I'm not an infectious disease specialist. I'm not a mathematician who can help the federal government right now. But if you want to know what they're trying to do, they're trying to figure out when does the tangent line become horizontal to the curve. Okay? So, a little bit of algebra review. Remember that a quadratic function is a second degree function. In other words, the highest exponent you'd see is the second power. You'd see x squared, you don't see x cubed, x to the fourth, and so on and so forth. So the standard form, and the shape of the graph is a parabola. So remember that the standard form of a parabola comes in the form y equals ax squared plus bx plus c, where a, b, and c are real numbers. So I know that there's a whole bunch of variables. I put them in light gray in pencil to show that there's going to be like 2x squared plus 3x plus 4 or something like that. Those a, b, and c are going to be actual numbers. The only variables that we care about are the f of x and the x. So you chances are you see a standard parabola or a reflected parabola. So the goal for this particular unit, right, even though it's Algebra 2, we're going to do this with harder and harder problems. We want to find the vertex of the parabola. In other words, we want to figure out where the lowest point is or where the highest point is. So the goal is to find the vertex of the parabola, but in particular, we pay attention to the a of the coefficient, the ax squared. The ax squared tells us whether it's going to be a standard parabola or a reflected parabola, or as my 11th grade teacher used to tell us, happy face parabola or sad face parabola. So what tells us that in Algebra 2? Well, for quadratics, if a is positive, so +1, +2, +3, and so on and so forth, or even like +1/2, or 0.3, or 0.1 even, then it doesn't matter. It tells us that the vertex of that parabola is the lowest point. And if a is negative, so let's say -2, -3, -4, or -0.1, -0.5 x squared, -0.75 x squared, as long as it's negative, that graph is a reflected parabola or a sad face parabola. Happy face parabolas have a lowest point, sad face parabolas have a highest point. And that determines, and the A tells us whether it's going to be happy face with a lowest point or a sad face with a highest point vertex. So without further ado, do as I say. Don't question authority. Do as I say. So just without further ado, here's the Algebra 2 review. So let me get my multicolored pen since I dropped it. So let's say I want to figure out the vertex of the parabola. I'm doing multitasking right now. I got the computer to my right, and the notebook right here. So without further ado, find the vertex of this parabola. So this takes me back. Remember that A is 1, B is 4, and just for the heck of it, C is 5. We don't really need C, but it's just... Anyway, so is A positive or negative? A is positive, so that makes it a happy face parabola with a lowest point. Do as I say. Don't question my authority, because algebra is do as I say, and calculus is, well, why does it matter? Anyway, I'm being silly. So step one, they told you that in order to find the x-coordinate of the vertex in standard form, you need to do negative b over 2a. Do as I say. So b is 4, and a is 1. So you get negative 4 over 2, which means that the x-coordinate of the vertex is located at x equals negative 2. Once you figure that part out, you move on to step 2. Well, what's the y-coordinate of that point? Well, I'm going to plug in x equals negative 2 into the equation of f of x. So we've got x squared plus 4x plus 5, where I'm going to plug in x equals negative 2. Okay, negative 2 quantity squared. Well, negative 2 times negative 2, that's a positive, so that's positive 4. 4 times negative 2 is negative 8, and plus 5. 4 minus 8 is negative 4, and negative 4 plus 5 is going to be positive 1. Therefore, the vertex is going to be at x equals negative 2, y equals positive 1, and that, based on our analysis of algebra, that the stretch factor of the parabola, tells us that it's a happy face parabola with a lowest point. I'm going to check my work with this. So the vertex is at negative 2, 1. Very nice. Okay, moving on to problem number 2. F of x is equal to negative x squared plus 18x minus 75. So let's do this. Once again, I've got a equals negative 1, b equals 18, and c equals negative 75, just out of habit. So what does a equals negative 1 tell me? A is negative, so that tells me it's a sad face reflected parabola. So that tells me that the vertex is a highest point. Do as I say. Don't question my authority. Step 1. The x-coordinate of the vertex in standard form, just because, is b equals 18, negative b over 2a, over 2 times negative 1. Well, that leaves me with the top being negative 18 over 2 times negative 1, which is negative 2. Negative 18 divided by negative 2 is positive 9. So the x-coordinate of the vertex is located at x equals 9. Now, step 2, I'm going to plug in x is equal to 9. Negative x squared plus 18 times x minus 75. So I might need a calculator. Remember that the square is applied to the 9 and that negative is on the outside. So that becomes negative 1 times 9 squared. 9 squared is 81. So I've got negative 1 times 81, or negative 81. Okay, I'm going to need a little help with this. I believe it's doubled. 9 times 18 is, not 9 divided by. 9 times 18 is 162. So it's just a baseball thing. 162 games in a baseball season. So negative 81 plus 162, well, that's 81. And then 81 minus 75 should be 6. So just because I'm paranoid, negative 81 plus 162 minus 75, that should be positive 6. And it is. So positive 6, negative 81 plus 162 minus 75 is positive 6. So therefore, the vertex of this parabola is located at x equals 9, y equals 6. And because we know that a is a negative number, the stretch factor is negative, that reflects the parabola and makes it a highest point. So the highest point of this parabola should be located at 9, 6. There we go. Math is power. Okay, moving on to the next one. sorry about that. F of x is equal to 2x squared minus 8x plus 5. Do as I say. Just obey authority. A is 2. B is negative 8. And C is 5. So what you want to do is say negative B, which is negative 8, over 2 times A, which is 2. So then I get negative 8, which is positive 8, over 2 times 2, which is 4. 8 over 4 is positive 2. Now I plug that into the f of x formula, where I plug in x equals 2. F of x is equal to 2 times x squared minus 8 times 2 plus 5. Okay. 2 squared is 4. So that's 2 times 4. Negative 8 times 2 is negative 16 plus 5. So that'd be 8 minus 16 plus 5. 8 minus 16 is negative 8. Negative 8 plus 5 would be negative 3. So the vertex of my parabola should be located at x equals 2, y equals negative 3. Now, if I pay attention, I forgot to do this ahead of time. If I pay attention to a equals 2, a is positive, so that tells me it's going to be a happy face parabola, standard parabola, with a lowest point. Check my work with the computer. There we go. Okay, so then f of x is equal to negative 2x squared minus 20x minus 46. This will be the last Algebra 2 review problem. Then I'll go in depth through the calculus portion of it. Okay, so a is equal to negative 2, b is equal to negative 20, and c is equal to negative 46. Okay, well, a is negative 2, a is negative, so that tells me it's going to be a sad face reflected parabola, and that is going to be a highest point. So let me just get that part out of the way. It's going to be a highest point. Okay, so I've got b equals negative 20, so negative b over 2. Sorry, I forgot to do my catchphrase. Never ever question algebra. Algebra tells you what to do and you obey it. No, I'm just kidding. Over 2 times negative a, which is negative 2. So then I get negative 20, which is positive 20. 2 times negative 2, which is negative 4. And 20 over negative 4 is negative 5. Okay, so now I plug in the x-coordinate of the vertex into the f of x formula. So that'd be f of negative 5. F of x is equal to negative 2x squared minus 20x minus 46, where x is equal to negative 5. Negative 5 quantity squared is going to be 25. Negative 20 times negative 5 is positive 100 minus 46. Negative 2 times 25, that'd be negative 50 plus 100 minus 46. Negative 50 plus 100, well, that's positive 50. And positive 50 minus 46 is positive 4. So therefore, the highest point of this parabola is negative 5, comma 4. So, without further ado, getting the boring algebra part out of the way. Okay? Why do they tell us for the billionth time? No more don't question me. Why in Algebra 2 and Algebra 1 do they say that in standard form that the x-coordinate of the vertex is equal to negative b over 2a? So, our goal was to find the equation of the tangent line. So what they say is, we'll find the slope, f prime of x. Pretend that a, b, and c are numbers. So what you would do to calculate the power rule for ax squared, if a is a number and x is a variable, you would do 2 times a and then subtract 1. So the derivative of ax squared with respect to x would be 2ax. If b was a real number, then positive bx, the derivative of bx with respect to x would be positive b. And because c is a constant, it's an actual number, and there's no variable attached to it, then the derivative of c with respect to x would be 0. The derivative of any constant with respect to x is 0. So now that I've got f prime of x is equal to 2ax plus b, and if the slope is 0, that means that you have the vertex of the parabola. Now, solve for x. So now I'm going to undo the layers. So if I've got 2ax plus b is equal to 0, I'm going to subtract b from both sides. And that gets me 2ax is equal to negative b. And now I want to solve for x. Well, what's bothering my x? That times 2a is bothering my x. If I divide both sides of the equation by 2a, then x is equal to negative b over 2a. And that explains it. Because the x-coordinate of the vertex means that the slope of the tangent line is 0. Using calculus. So without further ado, that's trig. The long-term goal behind this lesson is you're going to deal with funky graphs. Yes, I said funky because I don't have that high of a vocabulary. You're going to deal with weird graphs. They're going to involve high-degree polynomials. You're going to get x cubed, you're going to get x to the fourth, you're going to get x to the fifth. You might get a fraction as an exponent. You might get trig functions. You might have to get a sine wave, cosine wave, tangent function. You might get some, I'm trying to think of what else would be weird, like natural logs and so on and so forth. But the idea is, let's just say I sketch a whole bunch of, I sketch this, peaks and valleys. I sketch a weird graph. What we care about are these red dots. And these are called local minima and local maxima. Local minimum would be 1 point. Local minima refers to more than one low point. And local maxima, same thing. Maxima is plural for maximum. So we care about the local minima, right? Minima, minima, minima. We care about the local maxima, 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 right? And we can do this with calculus. So step 1, we can find the local minima and local maxima by setting f prime of x equal to 0. Once you have the derivative, you set the equation, you set f prime of x equal to 0 and solve for x. Once you do that, you find the y-coordinate of that point. So let's just do 2 of these. I'm looking at the clock right now. If we have time for more, we'll do more. So let's just say I take this same problem number 1, and I want to find the vertex. F prime of x is equal to 2x plus the derivative of 4x is 4, and the derivative of 5 is 0. Step 1, find the derivative, set it equal to 0. Then we're going to solve for x. Minus 4, minus 4. So then 2x is equal to negative 4. Then we're going to divide both sides of the equation by 2, and we get x is equal to negative 2. And then once you're done with that, you go back to the, you plug it back in and solve for y. In this case, let's just go back to problem number 1, right? When x was negative 2, y was equal to 1. So that'd be the only thing. This algebra and calculus share that same step, where once you figure out the x-coordinate of the vertex, you go back and plug it in. X equals 2, y is 1. But that's the main purpose of it. Okay? Problem number 2. F of x is equal to negative x squared plus 18x minus 75. Okay, well, let's use it using the calculus way, where we did question, why does that negative b over 2a method work? Well, step 1, take the derivative. The derivative of negative x squared is negative 2x. And the derivative of positive 18x, well, that's just positive 18. And I don't care how big you are, negative 75. The derivative of negative 75 is 0. So once I figure out the slope, I want to figure out the slope of the tangent line becoming 0. I want to figure out, well, when is the slope horizontal? So negative 2x plus 18 is equal to 0. Negative 2x plus 18 is equal to 0. I subtract 18 from both sides. So then I get negative 2x is equal to negative 18. And I divide both sides of the equation by negative 2. And so x is equal to negative 18 over negative 2, which is positive 9. So when is the slope of the tangent line horizontal? When x is equal to 9. You go back to the original set of problems. So you plug it back in for x equals 9, and you would get y is equal to 6. Okay, 2 more. F of x is equal to 2x squared minus 8x plus 5. Well, where is the local minima or the local maximum? Okay, so let's do f prime of x. 2x squared, the derivative of 2x squared with respect to x is 4x. The derivative of negative 8x with respect to x is negative 8. And the derivative of 5 with respect to x is 0. So now that I've got 4x minus 8 as my derivative, f prime of x should be set equal to 0, and now we solve for x. So 4x minus 8 is equal to 0. We're going to add 8 to both sides. 4x is equal to 8. And then we're going to divide both sides of the equation by 4. So then x is equal to 2. You go back to what we did. So then the second step after that would be to plug in x is equal to 2. Let me see, that was problem number 3. When x is equal to 2, y is equal to negative 3, and that would be my vertex. Finally, for the last problem, f of x is equal to negative 2x squared minus 20x minus 46. So then the derivative of this function, f prime of x, the derivative of negative 2x squared with respect to x would be negative 4x. The derivative of negative 20x with respect to x would be negative 20, which is equal to 0, because we're trying to figure out, well, where is the slope of the tangent line horizontal? Now we're going to solve for x. If I add 20 to both sides, we get negative 4x is equal to 20. We're going to divide both sides of the equation by negative 4. Cancel out. And so x is equal to, that'd be 20 divided by negative 4, that'd be negative 5. So the x-coordinate of the point where the slope is horizontal would be at x equals negative 5. You plug it back in and you find y. And that y-coordinate was y equals 4. So the vertex of that function would be at negative 5 comma 4. So you notice I was very careful about my language. What I did not say is, well, in calculus, that's all fine and dandy that the f prime of x is equal to 0. We can figure out those points, but you haven't taught us whether that point is a local minima or a local maxima. I'm afraid you'll have to wait until 2 more videos. One video after this, and then I'll show you, well, how do you know whether your local extrema is a local minima or a local maxima? The next video will be about high degree polynomials and finding those x values. Have a good day.